Let's move on to Module 2, the business question. We can actually trace this back to this idea of scientific discovery. So science is a set of methods, a body of knowledge, and the means to communicate it. With respect to discovery, we basically start with an informed hunch. Right? We grow curious about a phenomenon, we explore it for a while, and then you formulate a plausible, what we call a conjecture, that helps describe it, explain it, or predict its behavior. That's our informed hunch. You then transform this informed hunch into a formal and testable proposition for which we call a hypothesis. We then study and measure that phenomenon. These measurements become data that we can analyze and use to test our hypothesis. From there, we draw conclusions based on the evidence that we have. Our data and tests may force us to reject that hypothesis. In that case, you'll have to go back to the beginning, or your hypothesis may corroborate, or basically you'll find evidence that the results agree with what you expected or suspected to explain or understand this phenomenon. Eventually, after repeated tests and through review by other experts, you may be able to put together a systematic set of interrelated hypotheses that have been proven to describe, explain, and predict this phenomenon. So we call this a theory, right? In other words, a theory is much more than just a careless hunch. So let's go back to this idea of a conjecture. And what I'm getting at is we can think of the questions or business problems that we develop as initially conjectures, right? We have some informed hunch about why something is happening, why it varies, why it went up or down. By definition, this is just a statement or proposition that's believed to be true, but it's not yet been proven or substantiated by enough evidence. And in fact, good conjectures are testable. We want to be mindful to weigh our conjectures against any evidence that we can find, including repeated observations or repeated data points. We can also look at potentially doing an experiment. We can leverage mathematical analysis. You may also do mental or logic experiments, or some combination of these. We also need to make sure our conjecture comprises several components, and these components need to be logically related to this phenomenon that we're studying. In other words, they need to be naturally connected, right? So we want to come up with a conjecture that really provides a strong explanation to why something happens. So after we then compare that to any evidence that we can find or collect, the conjecture could possibly still be completely wrong. That doesn't necessarily imply that it's a bad conjecture, right, or sort of bad informed hunch or bad idea as to why we thought something would occur or why something potentially impacts an outcome. So let's take a step back and think about this ideation phase, right? For example, COVID-19 cases rose after the holidays. Let's suppose we were more in the height of COVID-19. Obviously, vaccines have come out and have assisted with mitigating the spread. But what are some possible conjectures? Or what's a possible reason? Well, one might be that people traveled more, right? They might have gathered more or been in closer contact during the holidays. So that would be a sound, a sound and logical conjecture to explain why COVID-19 cases increased during that time period. So let's think about a business application. What are some conjectures you can develop that might impact business performance? I'll give you a couple seconds to think about that, and then I'll provide an example. So let's go to our example. Obviously, remote work is very popular right now, or has been recently popularized as a result, I would say, of COVID-19 and time at home. Suppose that we have this idea or informed hunch that remote work leads to higher employee productivity. We always are going to have some sort of dependent variable or outcome, and we want to try to find an independent variable that helps explain variation, in this case, in that outcome. So obviously sales would likely vary per employee, right? So suppose we have employees that sell products or services. The sales generated per employee would vary, right? And that's measured in dollars. The independent variable, or what we're trying to test based on our conjecture, might be whether or not that employee is remote, whether or not that employee is in office. Of course, there could be other factors that could influence variation in sales. So some control variables are variables that we want to control for, even though we're interested in just that remote versus not remote variable, are things like experience, right? Experience could impact production, age as well, gender, or other external factors, including time period, or suppose there were some sort of economic conditions that varied over time. So that would actually allow us to, if we had data based on employees and their sales, we had those independent variables, including that categorical variable which we care about, and control variables, we would be able to formally test that, and it would basically be formalized into a hypothesis in which we would look at the results of different hypotheses-based tests. In other words, we could use statistics, if we had the right data, to evaluate whether it is the case that being remote versus being in office actually leads to or suggests, I don't want to use actually, right? Suggest, based on the data we have, that there is a relationship between remote status and productivity. So let's talk a little bit more about that hypothesis. So hypothesis you can think of as a conjecture that's formalized that can be tested empirically. As I mentioned, there's a clear dependent variable or outcome. We can also call it a response or target. You also see that term or those terms used. Then we have independent variables that help explain or help us understand that dependent variable. We could also call those predictors or explanatory variables. We also want to ask ourselves, as we think about this, do the variables defined in our study, in the way that they're measured and compared, reflect the reality that we're trying to study or explain? So that leads us to Another element that impacts this is data and representativeness. So obviously we need data to test this or formally test this, and data provides that opportunity. So for example, a study, an experiment, survey, or any data collected from existing software systems or technology systems the organization uses should be representative of the group that we're attempting to study. It might also be possible that we need to employ sampling or use a sample of data as opposed to the entire exhaustive population. If it's the case, then we want to make sure that that sample is selected randomly. That gives us the best chance of that sample being representative, at least from a characteristics standpoint, to the population that we're trying to study. There's always going to be noise or uncertainty, and when we think of randomness, data always vary randomly because of the object of our inquiries, and the nature itself is also random. This random variation leads to that uncertainty. For example, stock prices are going to vary randomly or could vary randomly. Annual box office takings or annual box office revenue could vary randomly. And you could think of many more phenomenon in which that might occur where there's just movement and it's not necessarily fully explainable. But as an example, if we think about political opinions, if we picked a random sample of 1,000 people, we can't be 100% certain they're going to be perfectly representative of the entire country. For example, we might get a sample of response around their opinions in which 48.2% are liberal and 51.8% are conservative. We can't conclude that the entire US population is exactly that. If we picked another sample, it might be different, right? It might be that 48.4% are liberal and 51.6% are conservatives, and the third sample might also be different as well. These differences are referred to as sample variation. So you might often see a reported confidence. I'm sure during election times you follow the different news outlets and they try to cover who's ahead, who's behind. There's often a interval reported around that, right? So plus or minus of some kind. So let's sort of put all this together and put it in practical terms. So this is my sort of quick strike approach when I'm trying to develop a business analytics project. You can think of as the first one is the conject. So you should start with that hunch or conjecture about something you care about in terms of understanding why it varies, that phenomenon, and why it varies. So think about some KPIs or tangible objectives that might be important to the firm, or metrics that might be important that you want to better understand. You then identify data, so think about what data you have or that you might need to collect and relate it back to your original business question or business problem. Good question is, do we have the data or a good data source for this? This actually might mean multiple data sets need to be collated or merged, or multiple tables if you're thinking about a database or a data warehouse, right? So it might be stored in different areas, or it might be actually monitored or controlled by different function areas. We want to define Y and X So y is our dependent variable, x is our independent variable or independent variables, right, or x's. We want to apply the appropriate filters. That might be to a certain group, to a certain time period, that again relates back to our clearly defined business problem. We want to conduct the test, and that in itself takes some knowledge and is a science. So we want to determine the appropriate analysis and or statistical tests, and we'll get there. We're then going to interpret the results. This may actually require you to go back to developing a new conjecture, identifying different data, rethinking the variables that you use or filters, or even using a different statistical test. And as I mentioned, if we relate this back to CRISP-DM, this is an iterative process and cyclical, right? You're not going to get it through one run or in a quick swoop. From there, you provide recommendations and solutions and execute on them. Importantly, you want to monitor the effectiveness of these solutions, right? So that's basically my quick strike summary to help wrap up this idea of going from a conjecture to something that could be tested to using those results. And that would be the end of module 2.